Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at the last section of the Semester 2 final exam review and going over limits. Let's get started. So, here in problem number 16, we want to evaluate the limit as x approaches 3/2 of this function right here, negative x minus 3 over x squared plus x plus 1. Now, one thing that I've noticed with students is that they're very quick to go ahead and start trying to simplify the original function, but you should be trying direct substitution first. In this particular problem, if you try direct substitution first, you will not get 0 in the denominator, which means that you're going to get a limit. So let's go ahead and use direct substitution, plugging in 3/2 for all the x's. And this is what we would get here. Negative 3/2 minus 3 over 3/2 squared plus 3/2 plus 1. In the numerator, I want to go ahead and get a common denominator of 2, so I change the negative 3 to a negative 6/2. In the denominator, I know that 3/2 squared will give me 9/4, so I want to get a common denominator of 4 in the denominator, which means I change 3/2 to 6/4, and I change 1 to 4/4. Now, simplifying, negative 3/2 minus 6/2 gets us negative 9/2 in the numerator. 9/4 plus 6/4 plus 4/4 gets us 19/4 in the denominator. Now we can do keep, change, flip because we have a fraction over a fraction, so negative 9/2 times 4/19, and this will get you negative 18/19, which is our limit. So again, don't be so quick to dismiss direct substitution. You should be trying it first for a lot of these problems. All right, problem 17, we want to evaluate the limit as x approaches 3 of this thing right here, x to the 4th minus 81 over 2x squared minus 5x minus 3. Now, if you do try direct substitution first, which you should be trying, you end up getting a 0 in the denominator, which makes your expression undefined, so we need to simplify the original function first. Here in the numerator, x to the 4th minus 81, we're going to use difference of squares, but we're going to use it twice. First, it simplifies into x squared plus 9 times x squared minus 9, but then notice we have another difference of squares to use on the x squared minus 9. So after the numerator factors completely, we have x squared plus 9, x plus 3, x minus 3. That's using difference of squares twice. Here in the denominator, 2x squared minus 5x minus 3, it's going to factor as 2x plus 1 times x minus 3. There are a variety of different ways that you can get that. You could factor by grouping, AC method factoring, using the little x puzzle thing, and a box. I know some teachers teach it that way. No matter how you end up factoring this, it should factor into 2x plus 1 times x minus 3. Okay, so notice x minus 3's are going to cancel. What we're going to be left with is x squared plus 9 times x plus 3 over 2x plus 1. And at this point, if we try direct substitution with the 3, it's not going to turn the entire denominator into a 0. So now we're going to basically restart the problem, but with a simplified version of our original function. So the limit as x approaches 3, the simplified version of our function, we plug in 3, do a bunch of simplifying, we get 108 over 7 as our limit. All right, number 18, does the following function have any discontinuities? So keep in mind, for a function to be continuous at a point, let's say the point is x equals c, then the left side limit as x approaches c, the right side limit as x approaches c, and the function value at c all have to be equal to each other. So that's what this is saying right here. For this piecewise function, the piecewise function changes at x equals negative 3. Notice that negative 3 is where the piecewise function is changing shape. So we need to check that the left-sided limit as x approaches negative 3, the right-sided limit as x approaches negative 3, and f of negative 3, it's a small little typo, let's put the negative in there, it should say f of negative 3. We need to check that those three things are equal to each other for this to not have any discontinuities. So let's do that. We know that if x is less than negative 3, that's left of negative 3. So to do the left-sided limit as x approaches negative 3, we're going to take 4 plus x squared and plug in negative 3. Negative 3 squared is 9, 9 plus 4 is 13, so the left-sided limit is 13. If x is greater than or equal to negative 3, this represents to the right of negative 3, but also equal to negative 3. So for the right-sided limit, I'm going to take negative 4x and plug in negative 3. That's going to give us 12. Now, at this point, we can actually stop. notice that the left-sided limit and the right-sided limit are not the exact same number. Therefore, this function would be discontinuous at x equals -3. I took it one tiny step further. I went ahead and just showed what the function value at -3 is. But you can see at -3, when x is equal to -3, you're still using -4x. So you'd get 12. But that doesn't impact the problem because we can already see that the left and right side limits are not equal to each other. All right, in our last problem here on the limits review, we're not making very long, by the way, because we literally just finished limits about a week ago. So fairly short limits review because you've already had a limits review. So here we are, we have this graph, and we want to find these 4 different limits. The limit as x approaches -2 of this graph is first. So looking at -2, x is approaching -2 from the left and the right. So if I start to trace the functions, notice that the y values from the left are approaching -2, but the y values from the right are approaching -1. So the left-sided limit and the right-sided limit are not equal to each other, therefore the limit does not exist. Now we check the limit as x approaches 0. Well, here's closing in on 0 from the left and right. Notice that as I approach 0 from the left and right, the y values are all approaching 2, and the left side and the right side are approaching the same value. So the limit as x approaches 0 is 2. Now let's look at the limit as x approaches 2. So approaching 2 from the left, 2 from the right. Very similar to the first one we did. The left side limit is approaching -1. The right side limit is approaching -2. Left and right side limits are not converging to the same location. Therefore, the limit does not exist. And then finally, let's look at the limit as x approaches 3. So approaching 3 from the left and right. We can see that the y values are all converging towards -1. Now, keep in mind, here we see we have a hole at -3, but that doesn't impact the limit. That only impacts continuity. So even though there's a hole at +3, the y values from the left and right are still approaching -1, so the limit is still -1.